All right, well, welcome everybody. I'm Justin Santa Barbara. This is...
I'm Cyprian Hackman.
Yep.
Happy to be here in front of you for the first time.
This is it. This is a version of a talk that we're giving to the broader KubeCon audience in the sort of main track. And we wanted to bring the topic in front of this audience, the contributor audience, mostly because there we're going to be talking about how we have all agreed on this sort of great way forwards, and it's such going to be so wonderful and all that. And I'm hoping that here we can actually decide what we're going to do and get some agreement or some disagreement on that topic. So we'll go through the slides pretty quickly just to make sure that we're sort of all on the same page. Please heckle, please let us know where you disagree. And we'll try to get, we've rejigged the slides a bit to focus really on where I believe most of the disagreement will come, which is sort of on the later section about how we're going to tackle the problem. So we talk a little bit about, well, let me kick us off. We talk about sort of why we split up the monorepo, what we lost, and how we could get that back. Probably it's easiest to just talk about, like, in the beginning, you know, we had the Kubernetes monorepo. Everything was perfect. There were no problems at all. Everything was great. Oh, back in the good old days, you know, wonderful. But there were some good things going on there. And, you know, one repo meant it was pretty easy to make changes that cut across the whole project. And importantly, everything was tested together and worked together. And we had one version of Kubernetes released together. So things were simpler then in some regards. And that I think is the aspect which we have lost pieces of. So, do you want to talk about any of this? Yeah, very easy to make those changes across layers. One PR could change, you know, front end, back end, kubectl, the whole thing, the scripts to bring up your cluster all in one PR. And we had some tests that would actually test those things end to end on multiple clouds. To varying degrees, and if anyone can remember the details of the extents to which we actually had those on GKE and Azure, please fill in, because my mind is sort of blanky on those after all these years. And why did we stop? You know, we had a lot of technical issues, like GitHub performance, for example. We had a lot of people issues around, and we still have a lot of those people issues around scaling of people.
I think we discussed about those a bit earlier.
Yes, we have. And we had a lot of, we wanted to enable sort of architectural fixes. So basically, stronger boundaries, creating projects. And really what we wanted to do was this idea of, you know, this ecosystem of cloud or cloud native rather than being a Kubernetes project that was one big monolith. And there are a bunch of strategies we took to achieve that, like CRDs and webhooks and doing things, emphasizing work outside of KK and CRI and CNI and CSI and cloud provider extraction, and broadly those things worked. You know, with 127, cloud providers are out, hooray! And we have more or less achieved our goals. Most of the work now happens outside of KK. Like, we pulled up some vanity stats off GitHub. You know, we have 77 repos in the Kubernetes repo, Kubernetes org, I should say. 161 in Kubernetes SIGs. That's a lot. We have 242 repos using Kubernetes controller, 27,757 using that reference the Kubernetes tag, 47,000 that reference client Go. We just didn't want to put the landscape slide up here, but you can imagine the landscape slide instead. But the point being that, you know, that second repo on the left over there, Kubernetes, KK, is a tiny bit of where stuff happens these days. But now we have to put all this together and test it all to make sure that those 27,757 repos actually work. And that is, I think, the tricky bit. So we've gained a bunch of stuff here. Do you want to talk about how IPv6 and how we did that?
So IPv6 is one good example. I think initially it was supported since Kubernetes 1.4, but it was never actually tested with cloud providers because there was no support on cloud provider side, both on infrastructure and in Kubernetes. At some point, people started working on dual stack, and inadvertently they fixed some of the problems in Kubernetes. They added multiple IP address, they fixed node port, host network issues, and luckily at the same time, AWS, GCE, they released IPv6 prefixes, and it all became much easier. We started in cluster lifecycle with KOps to add features there to improve Cloud Controller Manager, which was now a separate component. And in the course of, I don't know, 6 months, with various people contributing, we ended up having some usable IPv6 setup with cloud providers. So it's a very good example of how things work outside KK with a minimal set of people.
Yeah, and there were contributions required to multiple projects, right? But it was still achievable and maybe easier, I don't know.
It required still some KK contributions, like the ones that fix stuff, fixing tests that were meant for specific areas without cloud providers, so they were not necessarily correct all the time. So Antonio Ojea helped quite a lot there. The cloud provider AWS was pretty easy to fix by ourselves, like contributing the PRs and merging. Because it was just cloud provider, it required only, let's say, a minimum set of people doing the reviews. And we got those in the course of, I don't know, weeks, instead of generally in Kubernetes, some PRs may end up staying for months, if not much more. So I think it was a big improvement.
And I think one of the things I think is difficult here is there's no way to test this in isolation. You can't test just one project at a time. So I think it's a really interesting case study for why we need these things. If we want to build features going forwards, we have to test now changes across multiple projects. There's no way to, so we send a PR to the AWS cloud provider, and it doesn't make sense without the other pieces as well. So it's a difficult one to test together. So yes, in summary, what we have lost, I believe, is that for Kubernetes administrators, although we have succeeded in breaking up this monorepo, we have a reasonable developer experience with some caveats around testing. But for administrators, like the problem that we now face, which I think is almost existential. Like when I think about why Kubernetes succeeded, where other open source cloud projects failed, it's because Kubernetes worked. And we risk losing that. The Kubernetes project as a unit no longer necessarily works out of the box because nobody is testing it together. And we haven't, in the early days, there was a pit of success where we had, you contributed to KK, you ran the EDE tests. Sorry? Hack various scripts, yes, and that pit of success at least meant at least it was one pit that we all jumped into together, right? And now we don't necessarily have that, and I think we need to make sure that we have that same quality, because otherwise, Kubernetes administrators, we're basically pushing that workload onto Kubernetes administrators or Kubernetes distributions. Yeah. And essentially, what does that mean? It means someone has to put all these versions, pick some subset of those 27,000 projects, pick versions of them, test them together, make sure they work together. And KOps does this. Other distros do this. But the problem is that we all do this separately. We don't collaborate very well with the sub-projects when we do this. And so there's very little, it's a very inefficient process that is not producing a great output today, or isn't necessarily producing a great output. If it is producing a great output, it's only because of effectively the hard work of the people in this room, rather than this pit into which we're all contributing. So how can we make that pit of success more successful? And we're going to talk a little bit in the main talk about like how we do things in cloud provider GCP. For this audience, you know, we're working with cloud provider GCP to make sure that we have end-to-end tests in cloud provider GCP that reflect how they want to be consumed, and that we consume cloud provider GCP and KOps in that same way. So what we mean by that is we're working on a manifest. Cloud provider GCP will produce a manifest and say, here is the manifest we expect you to use as a distribution or as a Kubernetes administrator. They will test that manifest with KOps, with other tooling. And then KOps will like consume that manifest and not some other manifest that we happen to have invented, because that's what we were doing before. And it turns out that both sides actually had problems. Like our manifest had bugs in it, and the cloud provider GCP had bugs in it because that handshake just didn't exist. And I suspect that, you know, every project distribution interaction has a similar potential failure pattern going on here. Like every subproject could test better, and every distribution could probably better communicate with the upstream or the sub-projects to better consume what they would like us to consume. And so here's our proposal. The agreement that we're going to present tomorrow to the broader Kubernetes community is that we have agreed together that sub-projects will publish manifests that are tested. The manifest is a statement of the sub-project saying, this is how we would like to be run, this is what we test. And the distributions will take that manifest and will run that manifest. Simple, right? If we can do this, if we can help those sub-projects test those manifests in real-world scenarios, in KOPS, in Cluster API, in kubeadm, in whatever it is, make sure we have those tests, and then make sure that the distributions use those manifests. Then hopefully we will catch a lot of the bugs this way. Not all the bugs. I call them like single component rather than single source rather than combination bugs. So if it's a single source bug with this one failure rather than I do this and I do this and that causes a failure, then we think we'll be okay. The belief is that most of the bugs are of that first category, the single source. There are plenty of combination bugs, and we'll catch those as well. But the earlier we can catch these, the better. Okay, so no problems, right? Okay, here we are. Now, this is where we need your help. We need to talk about the problems, why this isn't going to work. So this isn't going to work for a number of reasons, one of which is, to date, a lot of subprojects haven't thought about manifests as the thing they publish. So I guess, why haven't you thought about this? What are the problems that you're going to have to deal with? I know you have thought about this. We all thought about these things. A big one is that immutability. Do you want to talk about this?
So one of the issues that we notice quite often is that sub-projects or projects change their manifest in a way that upgrades are incompatible, like selectors. You cannot change those. So now we want people to be able to upgrade. We either have to change our logic, or we need to modify the manifest, keep the old selector, and just ignore upstream changes. But that's not scalable because we have many contributors also. They don't know exactly what we want to keep back from the upstream, and we end up with with broken manifest over and over because someone doesn't notice, approves a PR, and then poof, people complain that, hey, my cluster doesn't work anymore, you want to upgrade. Also, we have disruption. In some cases, yeah, it's simple, new manifest, new version, there's no changes except for the image version, but once you apply it, magic. Something extra is needed that wasn't added in the official manifest, or I don't know, some data changes and you end up again with a broken cluster. You go to the project and they say, oh, if you install it on a clean machine, it works perfectly. So yeah, and you want to talk about the SKU?
Yeah, I mean, I think the final one is just making sure that I would classify all of these as around what is a component going to publish, right? Are they publishing a static point in time? No, like you have to think about it in terms of people are going to have consumed the previous version of your component. They're now going to consume the new version of your component. And what is the migration strategy going to be for those people? And so in the past, I think we've just changed like labels pretty freely and label selectors pretty freely. And I think that sort of has to stop. Or we need to be a little aware of the potential impact on how it will be consumed. I think this is less important and less fun arguments maybe than the other two. So unless anyone has any comments here, I'm going to move on to the next slide, which is going to get even more contentious. All right, here we go. The other reason this isn't going to work is that there is no manifest, right? There is no one manifest. There are parameters. So the classic examples are the name of the cluster and the CIDR. And we don't have we have yet to agree a way where we can put those parameters and inject those parameters into, or communicate those parameters from the distribution or whatever it is that knows what those values are to the components. And ideally, the components wouldn't need them, right? But often they do. And so I think the question is, how can we agree ways that this works? One way we can do it is with well-known environment variables or CRD, a centralized CRD. But then we have to define what that looks like, right? And I think KubeADM had some ideas here, but I don't know if we've ever formalized that as this is what you should do. No? You want to speak to that?
We had a good shot in the... we had a quite good shot at it 4 years ago, something like that. The ideal state would be that we would actually move in the component configurations into the API server, but it's hard. So, and with the component standard group, we lost steam after some time, so we didn't actually manage to do that migration fully. So, well, I don't know. I mean, the possibilities still exist, and the ideas and some initial proposals, but it needs... well, it was funny to see this. Congratulations to everybody that has done this kind of cloud controller manager thing. I remember like 2016 in that KubeCon, like then we were starting to plan this and it was 1.6, so 21 releases it took us. and this is similar, I think, time frame. Did you have something to add to that? No?
Yeah, so I mean, we have some places where we could start, some places we could look at for where these values could come from and how we can communicate them. I suspect the real answer is going to be that we're going to try a bunch of things in a bunch of different components and not try to establish that this is the way, begin the mission, begin the 21 release march, right? I'm gonna go up the stairs. And rather than do that, I think we're going to just try a few things in a couple of different components, because we don't need a standard. We just need to agree how the consumer is going to talk to those components. If we can, maybe if Cluster API and KubeADM and KOps can agree, sort of, hey, for this component, we're going to use this approach and try it, and we might change it in future. That's probably the right way to do that. And after a couple of releases, maybe we can standardize it or have some momentum behind a CRD or whatever it might be that describes a couple of well-known fields. There will still be exceptions, and those can go via the same process. There's another challenge, which is how those things actually get, well, before we even get onto this one, there's another challenge, which is how those things actually get mapped, and I think the same answer applies. Like, do we use environment variables? Do we use template substitutions? Again, I think we'll try a couple of things. Environment variables are pretty clean, but I think don't work quite everywhere, so we'll have to see. On each component how it works. Do you want to talk about variants, or do you want to talk about this one? About variants? Do you want to talk about variants, or should I talk? I'll talk about it.
Among other things, environmental variables are tricky.
The comment was environment variables, among other things, are tricky on Windows, and that is an excellent point. They are indeed tricky on Windows. Are the values limited, or is it just the names?
The environmental variables are contextual to your current security context in a way that is not easily testable. It's a problem with testing on Windows, period, because it gets down to like which account started up the machine can affect it. So it's much harder. It's much harder to use those for testing on Windows. It's
More fun. Is there another comment, or no? Oh, Fabrizio?
We can have one mic here.
Oh,
if we
thank you.
actually had, yeah.
Thank you. When I think to manifest, in my mind there are two kind of problem. One is packaging. How do you bring manifest to people that want to use it? And then there is the problem of variable that you just discussed. While I look at this space, I think that there are two ways to approach it. One is to reinvent, and the other is to use something that is already there in the community. Why we don't simply, okay, what is the most used things out there? Helm, KApp, I don't know. Why we don't just pick one and go on? It is already there, we don't have to reinvent it, and we kick in immediately in an ecosystem. I don't know if it is a good path, but at least it is, I think it will give less attrition that reinvent the wheel.
And I think that's a great point. I think we have a slide coming up about is this Helm. I'm trying to talk about the problems first before we talk about the solutions. So yeah, maybe this is a good time to talk about this last one, which is variants. And I think this actually is, so Helm gives us a lot, and it might give us too much because it comes onto variants. For example, the Cilium CNI provider, there are modes where it has encryption and not encryption. And there are modes where it has VXLAN overlays and not VXLAN overlays and all sorts of various, what I would call variants. They are not parameters, they're not tweaking things, they're fundamentally different modes of behavior. And I think the question is, how many of those combinations are really supported? And this is where I think we get into, the flip side of this is we would ask that the components are publishing things that they are happy to stand behind, right? In other words, I think there's always this tension between a distro and the upstream packages, as it were, when the distro starts forking things. They're like, why did you introduce this patch? I don't want to support you anymore because you're 20 versions behind and you patched it, and it's like, what are you doing? Why did you do this? And there's reasons why we did that, why people patch things, sometimes good, sometimes bad. But I think what we do want is we want the ability for the subprojects to say, these are the things we actually intend to support. So if you want to use Helm to generate the 5 permutations that you actually want to support, that's fine. If you genuinely support as a component, 2 to the n permutations, then by all means use Helm. But my guess is that most subprojects, most components would actually say, you know what, there are these handful of configuration options that make sense, right? You use encryption, or you have a sort of high performance or ultra high performance mode. And then like a lot of the other combinations just don't make sense. And so that's why I think variants in this sense can work in that we can more go towards the static manifest here, is my hope, even if you choose to generate those manifests with Helm, because you actually only want to support a handful of options, right? And you do have to sort of say in this proposed contract, yes, actually we will support those. We won't be like, oh, you really shouldn't be using this mode, like, we'd rather you didn't do that. Can you change this flag to this flag and this sort of thing? Anything you want to add there? Okay, the final challenge is non-Kubernetes objects. So although it pains me, there are some things we can't express in Kubernetes. The canonical example being the ports that you need to open for CNI providers. There's also IAM on most cloud integrated add-ons. I don't know if it's a huge problem we need to tackle right away. It probably means that the distros will have some knowledge of what they're installing. They'll know that Cilium needs this port open. They'll know that the AWS CSI driver needs this particular set of IAM permissions. In future, it would be great to, standardize on crossplane or whatever it might be to be able to express those things in a more Kubernetes way. Maybe we come with our own language. I hope in that case we don't. But I think, again, we'll start off making things that work and then try to generalize here. Because we've spent a lot of time on this and we don't have a great answer yet. So this is not a new topic for many of us. Okay, so here's why, this is, I think, why Helm charts are not necessarily right. But please, heckle. Oh, sorry. Basically, it's still an API. We still have to decide all these things. And it implies a contract which doesn't exist, right? It implies that you're going to support all those things when I don't think you are as a component. I know for the components I maintain, which are not widely used, I certainly do not want to maintain a large set of configuration options, certainly not the full set of options that you can express through the flags. So here it is. Here's our proposed contract that we all are signing up for today. Stand up, declare, I declare. I'm just kidding. But effectively, components, please publish manifests which describe how your components will be used in production or how you would like them to be used in production. And please test with those manifests in using the production tooling. And then on the other side, the distributions, we will help you with that testing with our own production tooling. We're obviously each incentivized to do that, so hopefully KOps will help each one of the cloud providers and CSI drivers and CNI drivers and CRI drivers to get their own E2E tests going. Hopefully kubeADM will do the same. Hopefully Cluster API will do the same. And then our other thing is we won't deliberately patch your manifest. We won't mess with you just for the sake of it. We'll at least talk to you first. So in other words, you will know that KOps isn't shipping some horrible fork of your beautiful provider if you follow this sort of contract. This is the deal that we're sort of thinking is our way forwards. And if we all sort of agree to this, then we can actually eliminate a huge class of the errors that we have had to date, and we can make it that when you do this work with KOps, that same work benefits Cluster API, benefits kubeADM. If you do it with Cluster API first, we get it for free on KOps, so that would be awesome too. Whatever it is, but we don't have to do the n-squared combination of things, and we can get back to a world where the final distribution, or distros, are actually very well tested. We catch failures as early as we did when we were all running in KK. And the final product is of very high quality without each of the distributions having to recreate all the work of each other.
What about security? So what I mean, you mentioned ideally we publish production manifests. For example, metric server has been publishing production manifests for long, but they are not secure because we cannot guarantee security because 99.9% of Kubernetes distributions don't configure or don't sign certificates properly. How do we go around distributions doing unsecure things because they can?
Great question. I mean, I think we should have that conversation, and you should make us do the secure one. So you could publish a variant that says, metric server, horribly insecure, do not use, and metric server, right? But we should be, if there's something the distributions aren't doing, we should be that we could easily be more secure on, we should fix that, right? But this is how we fix it, I think, is the answer. Do you want to give it?
I think, at least from my knowledge, KOps has certificates, doesn't use insecure TLS through something. But I agree, it's the easiest path for most people to say insecure TLS, and why do I need it for metric server? Okay, moving on. Unless there's a better mechanism, distributions would have to take care of these certificates properly. Not sure if there's any way around it, but yeah.
I assume that you meant that kind of in-cluster, not the Kubernetes cluster itself, but kind of the components talking to the APIs or the controllers. The webhooks. Okay, but see Nick joined here as well. We were actually yesterday talking about the operational complexity of the webhooks from the API server from a perspective of an operator developer. So I'm doing my operator, I need to have a webhook for mutation and validation and whatever conversion. Now, how do I get those certificates and provision my setup to the API server in a sane way without kind of, especially when I upgrade my manifest, how do I keep the same kind of trusted connection to the API server without kind of breaking everything? And then like the other thing that we spoke about there as well was that in some clouds the CNI is not installed on the API server, which means that you don't even have the access to these kind of webhooks. So I think that is one of the main ones in this, because most of these extensions or these kind of manifests are those that will effectively change the cluster operation.
Yeah, I think we're out of time, right? I think we should extend and move the contract forwards to make sure that we agree what these things are, who's responsible for these signatures. But I hope we can work together using this as a basis. So at least we can try. And there are problems, and I think we can overcome them together. So thank you everyone for the wonderful feedback today, and let's continue the conversation, please.